Suppose we have collection of charges, right? Let's say we have this one charge q1, another charge q2, and this charge q3, and so on. And let's say we have a fourth charge q4, right? Okay, let's take four charges system. Okay, I want to know the force on this q4 particle, right? Now what will happen? See, the force due to Q2 charge on Q4 will be in this direction if both of them are positive or negative, right? Let's assume all of them are positive. Now Q2 will apply a force like this. So we will call this force as F, force on the fourth charge due to the second charge, that is F4 2 bar, right? The force by the third charge will be in this direction. So this is the force on the fourth charge due to the third charge. So I will write F4 3. The force due to the first charge on the fourth charge is like this. So F4 1 bar, right? So now the force on Q4 charge is the addition of all these charge, all these forces, right? The force on the fourth charge is the addition of all these forces. That itself is called superposition theorem. Okay? So the force due to the second charge on the fourth charge is not affected by the force due to first charge on the fourth charge. Neither is it affected by the third charge on the fourth charge, right? So all of them will act independent of each other, and the net force will be given by this addition of the forces. That itself is called superposition theorem, right? So it doesn't matter, okay, it doesn't matter what other charges are applying forces. The force due to that charge you find out and add it, okay, and then all of the resultant force, all of the forces if you add, then you will get a net force acting on that charge, the total force, right? Okay, so now let's write this in a proper vector form, okay, like given in a textbook. Let's do that. So we have a coordinate system like this. This is x, y, and this is coming out to be z, right? Okay, and we have many charges, n charges, let's say. Okay, so this is ith charge on which I want to find out the force. This is the first charge, this is the second charge, okay, this is the third charge, and so on, right? There are n charges, I don't know, n charges, capital N charges. Now the force on qi is the force that I want to find out, the net force, right? So what I am going to do, I am going to draw this is origin, by the way. I am going to draw the position vector for the ith particle ri bar, and the position vector for the second charge is r2 bar, right? The position vector of the second charge is r2 bar. Now the distance between these two vectors is this, and if I write this vector, this will be ri bar minus r2 bar, right? Ri bar minus r2 bar. The force on the ith particle due to the second charge, okay, the force on ith particle, ith charge due to the second charge is given as k qi q2, you know this, divided by distance square. Now ri bar minus r2 bar can be written as this. Ri bar minus r2 bar is written as this. I have told you this notation previously. Okay, if it is r1 bar minus r2 bar, it is r12 bar. If it is r3 bar minus r2 bar, it is r32 bar. This is a notation. Now this ri bar minus r2 bar magnitude square you have to divide. Now the direction will be what? See, if all of them are positive charges, the direction will be along this vector itself, right? So it is ri2 cap, right? So this is the force on the ith particle, ith charge due to the second charge. Similarly, the force due to first particle on the ith charge is force I1 bar. Okay, so this will be KQI Q1 upon Ri bar minus R1 bar mod square Ri1 cap, right? And so on. Okay, so the net force acting on the ith charge is nothing but the addition of all these forces, Fi1, Fi2 up to Fin, right? So that itself is a superposition theorem. So here I write Qi1 Q1 upon Ri1 bar mod square Ri1 cap plus KQiQ2 Ri2 bar mod square Ri2 cap up to KQiQn upon Rin bar magnitude square Rin cap. Okay, so this is the net force acting on the ith charge. Okay, correct. Okay, so this was the superposition theorem. In the next video, what we are going to do, we are going to do some problems for the Coulomb's law in a vector form, right? Let's look at that in the next video. Thank you.